Okay, this is the Math 1113 first Zoom meeting of the semester. We have some students who came out. Appreciate y'all coming out. First question tonight was about the WebAssign, how to get to the WebAssign problems. Have you gotten to this screen? Or do we need to back up and show how to even get to this screen?
I think that I'm at the same place. Mine looks a little bit different from what you're looking at.
That's the problem. I'm on the instructor.
I'm in the personal study plan.
Okay, good. Yeah, so the way I get the personal study plan, I have to open the student view. That lets me get to a screen that hopefully looks more like yours. Okay, does yours look more like this? So yeah,
yes, and then I go to personal study plan.
Right. So yeah, if you go down to,
and I click for explanation.
Start with chapter 4. And then this week we are doing 4.1 and 4.2 here. And I'm taking all of the problems off these practice quizzes. Now I don't have my camera up right now, so you're not going to see but I emailed out this assignment, and in 4.1, you were supposed to work problems 1, 2, 3, 4, 5, and 8. I'll show them. So I hit the practice quiz. All right, so it's problems 1.
Okay, so I was supposed to go into the practice quiz.
Yeah, practice quiz here. 1, 2, in fact, the first 5, 1, 2, 3, 4, and 5. If you got your graphing calculator, you should be able to, enter those functions and be able to match graphs here. And then you click on the circles. 3, 4, and 5. And then I had you skip down to 8. Yeah, I don't want to mess with increasing and decreasing. In 7, I didn't want to mess with. And 8, 8 should be pretty straightforward if you know your formula. So,
okay, thank you.
Okay.
Just wanted to make sure I wasn't doing the wrong problems.
No, not a bit. Now, here's the thing about this stupid program. The problems I'm showing you will not be exactly what WebAssign shows you. It likes to scramble things. So your number 8 will not read exactly, it'll change something, but it'll be pretty similar. All right, the idea is, if I can go down to the bottom, is that you can work a problem, and here's where you submit. You can work all the ones I've asked for and then submit, or you can work them one at a time and submit. When you get them right, I believe it gives you a green check, and if you get them wrong, you probably a red X. So the idea,
yes,
go ahead.
Yes.
Yeah. So the idea is you can work them, you get a green check, great. You go on to the next one. Work it, submit it, get a green check, great. All right. The idea is don't pay attention to WebAssign's grade because I've skipped some of these. The WebAssign is going to have you a lot lower because it's going to mark the ones we skipped wrong. So the idea is I counted 14 problems between section 4.1 and 4.2. And all you got to do is tell me you get all 14 right, 14 green checks on the problems I asked for. Then you tell me, Mr. C, I got 100%. I write that down. If you miss one wrong and you don't want to, go back and look at it, and you get all the other 13 right, then tell me 13 out of 14. I'll write down that percentage. Is that as clear as Lake Lanier?
Yes.
Okay.
Yes.
So we just email you saying, hey, we got this out of this?
Yep.
Awesome.
Next week, we jump to sections 4.3 and 4.4, but it's going to be, from the same spot, personal study plan, down to chapter 4, section 4.3 practice quiz, 4.4 practice quiz. But
is there a cap on how many times that we can work a problem?
No, you can work them as many times as you like. The thing is, you're not going to get exactly the same problem when you redo it. That's what drives you nuts. So you get it wrong and okay, I want to do it on a similar one, and it gives you a similar, it does not give you exactly the same problem, it gives you a similar.
Something that I've noticed trying to do all 10 problems right, the only things that change are the numbers in red. Everything else stays the same for each problem.
Okay. Okay. But yeah, I will pre-screen, no, next week I'll pre-screen the problems and give you only certain ones to work. Okay, did we kind of buried you in material, an overview, a syllabus, a calendar. And then I gave out 2 videos going over those, and I put a 4-digit code in the 2 videos that if you email me, I give you 5 points extra credit on the first test. Did anyone want to ask anything about that?
No, it seemed pretty straightforward.
Okay. Oh, I didn't think to ask this in the statistics, but has everybody found their way to the syllabus, the mandatory attendance quiz and the discussion post you're supposed to make?
I finished them.
Okay, I didn't quite hear that, but did everyone know how to do that?
Yeah, it's over D2L.
Yes.
Right. The mandatory attendance quiz is under quizzes. It comes right up, and the discussion post it comes right up, mandatory discussion post. I'm just noting names of everybody who does both, and we count you as attended, and you're great. If you're missing either one or both, then yeah, it's a problem. But you got till next Sunday. Did anybody want to ask anything else? Did you want a little intro to the problems of this section?
Sure.
All right, well, let me turn on the camera. Take a couple of minutes, so be patient. I'll have to stop the share and go to the camera. Oh, we've got 7 participants. That's one of them's me. So we got 6 people out tonight. Appreciate y'all coming out. I'm gonna turn my camera off. I like my camera off. If I can, yeah. All right. Let's see if I can get the camera up. Okay. So this is what I was trying to explain in the videos. I can write any random problem out, work any random problem you want to see right in front of you. Can everybody see this?
Yes, sir.
Yes.
Okay.
Yep.
So this is just like writing on a blackboard right in front of you in a normal classroom. There's nothing high tech about it. It's my iPhone 6, and I'm using a share application with it, between it and Zoom. So yeah, most people found this pretty helpful last semester. I have to say, it worked pretty good about 95% of the time. But I live out in rural Hall County, and occasionally the Wi-Fi, I've got the best Wi-Fi they supply I can buy from AT&T. But it occasionally freezes. Sometimes my son, today anyway, sometimes my son is doing his online classes, and it's a little too much, me doing a Zoom and him doing a Zoom. It's a little too much for our Wi-Fi, I think. But I'd say it worked pretty well about 95% of the time, but it occasionally freezes. but it worked well enough to that I think it's very helpful. I can show you know, the book underneath it. I can write. So class is going to start at section 4.1. With exponential functions. This is a repeat of, chapter 4 is a repeat of our college algebra, chapter 4. And then in chapter 5, we hit trigonometry. But if you're used to, in 4.1, used to y equals x squared, that's a polynomial. You reverse it, y equals 2 to the x. So your base is constant, the x is your exponent. That is your exponential. And so if you graph it, x, say, versus 2 to the x, we can start out with 1, 2, 3. Most everybody can get that right. You're 2 to the 1, you're at 2. 2 squared, you're at 4. 2 cubed, you're at 8. Does everybody remember your zero power rule? Anything to a zero?
Times 1.
Did I hear it? It was always 1. All right, so then you have -1, -2, -3. Y'all remember how 2 to a -1 works? You regard it as a fraction. You switch it down when you do, the power changes sign. 1 over 2 to the 1, which is 1/2. You can punch it on a calculator, you'll get 0.5, the decimal for 1/2. Can you tell what 2 to the -2 would be? 1 over 2 squared, 1/4. You see the pattern? 2 to the 1 is 2. 2 to the -1, 1/2, 1 over 2. 2 squared, 4. 2 to the -2, 1/4. Can you tell what 2 to the -3 would be? 2 to the 3rd is 8. 2 to a -3 would be 1 over 8. We losing anybody?
Nope, all clear.
Okay. So if we graph this, you can start with 0 and you get up 1. That's the y-intercept. Over 1, you're up 2. 2, you're up 4. 3, you're up 5, 6, 7, 8. You're up 8. It's called exponential growth. All right, well, when you go in the other direction, -1, you're down 1/2. You're a factor of 1/2 smaller. And -2, you're at 1/4, 1/2 of 1/2. -3, you're at 1/8, 1/2 of 1/4. Do you ever touch the x-axis?
No.
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 Everybody know the name for that x-axis starts with A.
Asymptote.
Very good, asymptote. So that is 2 to the x, or a graph of it. All right, if you look at the problems, we can charge through some example problems here. I think I did number 7 in the introductory video just to illustrate the camera. So maybe I'll do the second part of it. Number 7, first homework, 4 to the x. I think I did f of 1/2 in the video. So I'll do the next one, f of √5. 372, number 7, f of x, 4 to the x. Let's say f of square root of 5. So we would want 4 raised to the square root of 5 power. If I can find my calculator, my outstanding class preparation, there it is. So yeah. You can see it here. 4 raised square root of 5 power. 22.1946, I guess. Y'all think you can handle these?
Yes, sir.
Okay.
Yes, sir.
Very simple.
All right. The next section's about graphing on the calculator. I just use the calculator to punch in a formula. Do you want to see one of these things graph? Now, I just graphed 2 to the x by hand. Do you want to see it graphed on the calculator? It says sketch a graph by making a table of values. I just did. You don't have to do that. You can just use your calculator. Anybody want to see an example done on the calculator?
Sure.
Okay. So 11 is 2 to the x. We'll do that on the calculator. Graph f of x 2 to the x. Y equals, clear, 2 raised to the x. Don't worry about that little blip. I guess this is a very old, oh, wait a minute, I must have marked it or so. All of a sudden it's smeared. Now I'm just making it worse. Okay, I just got a magic marker smear. All right, now that you enter your formula on y equals, you go to window. Very common window is -10, 10, 1, -10, 10, 1. We're going to be graphing trig functions starting in chapter 5. So we're doing a lot of graphing. And then finally, the graph command is there at the end. And sure enough, there you are. There's the graph on the calculator. It looks like it might just start right there and you go up, and then this is your 1. But it doesn't. It goes forever. The calculator it just gets so close to the x-axis, the calculator can't show it to you. Questions about that?
I'm all good.
Okay. So then the next section of problems is 27 to 39. And 27 to 39, and these are off page 373. They're asking you to graph and state, domain, range, and the asymptote. So if you look at 27, g of x equals 2 to the x subtract 3. All right, now I just did 2 to the x. This is 2 to the x, but they're going down 3. Anybody remember from your basic college algebra what -3 out there would do to 2 to the x?
Would it shift it to the right?
Okay, if the minus were up here in the exponent, -3 up here, then yeah, that's right. That would go to the right. But out
I
here,
believe that it would shift it down
down,
3.
down 3. Now that's how the directions say they want you to graph. You don't have to. You're free to use the calculator. But yeah, this is going down 3. You're free to punch it in and just copy what it gives you. So basically, if you take this down 3, you're going 1 to the x and then 2 more. So you want to show the original. You're going 1, 2, 3. And then notice that this asymptote's 1 level lower than that intercept. So you're going through there and up, and it just makes a perfect translation down. I want you to list domain. Everybody remember that infamous word from college algebra? X-min, X-max. Can you tell your X-min is going to the left to X-max? Can you tell what they are?
-infinity to infinity.
Infinity, right. You can also say all real numbers, but yeah, an interval notation. Stick any, but basically in plain English, you can stick any number into this. There's no problems. Range. Y min, Y max. Now you're thinking vertically. So range, you're thinking vertically, domain, horizontally. All right, well, you got to start. You see, there's nothing lit below here. So you're really starting at -3. You're going all the way up to infinity. All right, do we need a reminder about interval notation, or do everybody remember your interval notation? Everybody kind of went dark on me. Nobody said anything. You'd always put parentheses around the infinity. You remember what you put parentheses or bracket here? Notice remember, it never touches this. So it's never equal to -3. That would stick a parenthesis.
Since it never,
Yeah, go ahead.
sorry, I thought you were asking us.
Yeah, no, go ahead.
I was going to say, since it never touches, you put parentheses. I thought you were trying to get us to solve it for you.
Yeah, I kind of was, and everybody went blank on me. I don't know if, at least I didn't hear anything. That's the kind of strange thing about teaching online. But yeah, if it had crossed -3, you understand you would have put a bracket.
Yes.
Okay. Brackets mean you can be equal to these n numbers. Parentheses mean you can't. You always stick parentheses on infinities because they are not numbers you're ever equal to. It just means you're getting bigger and bigger and bigger. Does anybody want to see any other examples of that? You can enter them in on the calculator and you can read pretty much all the domains are going to be -infinity to infinity. All the domains are. There's no problems with exponentials. But you're going to have to look at a graph to figure vertically what your ranges are, and they're different in every problem. Y'all think you can handle those?
Yes, sir.
I think we got it.
I think we're good.
All right, well, the very last subject is your compound interest. Say over here. We covered this in college algebra. They'll give you an amount of money, deposit an account, give you a compounding. And this one, they want you to complete a table. Others, they just want you to pop the numbers in. So I hope everybody remembers your compound interest formula. This formula look familiar?
Yeah, it's very familiar.
Okay. That's your principal, money you put in. R is your interest rate. T is your time in years. And N is your compounding periods. Now, they usually don't directly give you, they'll give you numbers for everything there, the R, the N, the R, the T, and the P. The N, they usually give in words, and you're supposed to, like, okay, so if they say yearly, 1. Semi-annual, or they might say annual. Semi-annual. That would be 2. Everybody get the idea? Monthly. Let's say compounded monthly. So N would equal 12. So as long as you know your formula, it's pretty much plug and chug and punch on the calculator. Why don't we try 55? At least we won't fill in the whole table, maybe just the first part of it. So we're looking at 4%, 5,000, 4% for 1 year, compounded monthly. This is page 373. 55, R is 0.04, P then would be 5,000. Your N would be 12 compounded monthly, and your T would be 1 year. Are we losing anybody?
No, sir.
Okay.
All good.
All right, so I won't rewrite the formula down here, it's up here. Plug and chug, you have 5,000, 1 plus 0.04 divided by 12 raised to the 12 times 1, actually, times 1 on the first row anyway. So we will punch away. Now I don't have to show the times 1. I can just hit enter, and 5,000 has grown to $5,203. $5,203 point, I call it 7.1. Y'all know about your editing. In the next line, it's 2. So if I call it back, I can hit times 2. Nothing changes except the T changed to 2 years. And in 2 years, I'm at 10,400 and, wait a minute, what am I doing? Oh, okay, yeah, see, this 5,000 doesn't grow to 10,000 another extra year, except in fantasy banks or some monopoly money or something. Yeah, can you see my mistake? I'm getting careless. Late at night, I'm getting careless, a little tired. Can you see my mistake?
Yeah, we see you.
You're not going to tell me what it is, but you see it. Okay, I got it.
You didn't put it in the parentheses?
The 12 times 2, yeah. Yeah, very good. So would anybody have just blindly written down the 10,000, or would you have thought, gee, you know, there's something off. 5,000 doesn't grow to 10,000 that quick. Well,
I mean, it's a little bit shady, but you know.
yeah. Okay, so
And
54.
turn down that extra $5,000.
That's right, 5415.71. That's a little more reasonable. So for T equals 2, it's 5417.71. Yeah. Okay, yeah, the only way to go from, say, 0 to 10 million riches is to win the lottery. And there are lotteries out there, but your money doesn't grow like the lottery. Does anybody want to see more examples of that?
No, it's pretty straightforward.
Okay, that pretty much finishes 4.1. We're at almost 30 minutes. Okay, I try to keep these sessions to 45 to 50 minutes. We might go quicker tonight because this is pretty much review. But 4.2 we're going to cover this week. It's the number E. Natural exponential, and hopefully it's a review for y'all. It comes from, I'll rewrite the formula on the compound interest formula on the next page. Basically, if you let the n tend to infinity, this middle here, and you get E. I don't know if they've punched it out. I don't know if y'all have the patience for it. Hopefully it's a review. So what they do is that the magic phrase is called continuous compounding. And that means the n is tended to infinity. So you're not doing it monthly or daily or yearly or annually or anything. You're kind of continuously calculating the money you have, running it through this formula and putting the money back in. And that changes the formula under that magic phrase to PE to the RT. There's no N in it. The N has changed to this number E. Does everybody remember what that number is? 2.718.
2.4718.
blah, blah, blah. It goes forever, just like pi. And it's so important that it's got its own key right above the ln key, e to the x. I don't know if y'all can see that, if I can get the blinding off, but I'm sure you've, yeah, right there. All right, well, they give you some compound interest problems in the book, and they give you some kind of little more complicated kind of formulas. I think we started with number 3. It's the same idea. Do we need an example of that? H of x is e to the x, and then they want h of 1, h of pi, e to the pi, in other words, e to the -3, e to the √2. Anybody need to see those punched, or y'all expert calculator punchers?
I think I'm all good.
Okay. So you go to the next page, and I think I started up with 23, and they kind of give you these in word problem form, but they're really nothing but, calculator punching. They have to give you the formula. 23 is about drugs. 25 is about skydiving. You see a little more complicated formula with an E in it. 27, let's see, 20 is about, a little more complicated. You got to read the numbers out of the chapter to plug them in up here. 29 is about world populations, got a little more complicated. And then they get into continuous compounding over here at 31. 3%, fill in a table. Putting 7,000 when you're continuously compounded. And then over in some of these, you get comparison, like 35. So it's got when you do annually, semi-annually, quarterly, that's the formula from the previous section. Then they switch to the E formula and D with continuously. Any of these leaping out at anybody, crying out, do me? Do we need an example of punching any of these?
I feel like I got it.
Okay.
Yeah, they seem pretty straightforward.
Okay. Anybody came out tonight? How many participants are we? Did we keep anybody, or anybody drop off? Oh, we one dropped off, but that's fine. There's no attendance requirement or anything. Anybody out there? We got 5 people. Anybody out there just dying to see any of these? Or are you just dying 9:30 at night?
I do have one question just in general for pre-cal. Will we have to know the unit circle?
Yes.
Okay.
It'll, I'll start going over that in chapter 5.
Gotcha.
Yep. Coming attractions. All right, then, you will. Again, these problems are practice problems out of the book. They will not directly be taken up for a grade because I have no way to do that. You would be writing them out. You'd have to scan it in, send it to me. I'd have to print it out, write my grade on it, rescan it, send it back. It's just overwhelming. So on Friday, we're giving out a quiz 1, and we will explain the format later in the week of that. And quiz 1 will be based on these problems. I really don't want to get into it tonight. I don't want to overwhelm everybody. We've given you a whole lot with the syllabus calendar and everything, a lot of information at the start. So end of the week, we will show you the format for quiz 1, but it will be based on these practice problems. So we will be getting your grade from these.
So I do have a question for you real fast. I was looking over like the Zoom stuff, and I know you recorded videos for everything, but is there like Zoom lectures at all?
No, this is the Zoom lecture right here. So I do not pre-lect like I do not, like in a regular classroom, I'd stand up and lecture. but I was advised not to do that. So I sent out a little instruction email if you happen to get it. If you look at the ebook, they've got lots of videos if you want to see them about all this. You can get on YouTube. You can type in the section titles in YouTube and do a search for videos, and you'll find all kinds of teachers who have stood up and were happy to give you their lecture, and you can watch it on video. Khan Academy is out there. It's free. It has entire courses that fit this. So I was advised not to reinvent the wheel and do my own videos. So you are basically getting, I'm here to answer your questions and to work any problems you want to see. If I think it's appropriate that there's a concept out there that I'd like to give my version of it, then yeah, I may take 5 or 10 minutes in one of these Zoom sessions and give you my little short Reader's Digest lecture about it. But otherwise, no, I do not lecture through these Zoom sessions.
All right. Well, I appreciate it.
Okay. Now, what I do like to do is do like a Zoom section or sessions early in the week. And I did this one late at night because, like I tried to explain, I didn't want to run into Wi-Fi problems first day of class with everybody on the network. And then I like to do Zoom sessions toward the end of the week. So in other words, you get the middle of the week to practice the problems and we'll look at them. And then if you got questions about them, you get a Zoom session at the end of the week to ask about it before we do the quiz on Friday. I guess I should ask, do y'all like night sessions for Zooms or do you prefer day?
I prefer the day.
Daytime, most definitely.
Daytime. Now you see, I got 32 people, so trying to find a time that'll make everybody happy is darn nigh impossible.
32 people.
Here.
No, they're not here. You're right, tonight. They might want to come to future ones, who knows? Personally, I prefer 8 in the morning because I like to get on, get it over with and get it done. And then I can go out and do what I really like to do. Not that I don't like to do this, but etc. Is 8 in the morning too early?
A bit early.
Bit early.
Just a little bit.
Just a smidge.
Okay. Well, I did it last semester and nobody really complained. Of course, I didn't really have any attendance either, live attendance, but I do record all these and post them to YouTube. Would that be sufficient if I did do 8 o'clock ones?
Yeah, that would work.
Okay. So yeah, this will be, when I stop the sharing in the meeting, this will be converted and recorded to YouTube and posted to D2L. Look for the links to the Zoom meetings in D2L. In the very left column, you'll see a button down toward the bottom of it, says link, it'll say link to Zoom meetings. And it'll just build as I post them as the semester goes on. By the end of the semester, there'll be hours and hours of these Zoom meetings there.
Sounds good.
Perfect.
All right. Is any other questions before we?
I think I'm all good. Thank you so much.
Okay, well, sure thing. I will make sure this gets recorded and posted to YouTube. Not that y'all will probably want to watch it again, but for everybody else that didn't come out. So hearing nothing else, we'll go ahead and end the meeting.
Thank you, Dr. C. Appreciate it.
Sure
Thank you
thing.
so much. Have a great night.
And to you. Appreciate you coming out.